To encode the robot's capabilities into a linear temporal logic formula using sensor data, we perform multiple executions of each skill to learn an abstract representation of the skill. Shown here is skill B2F. We then encode when the skill is allowed to be performed and its effects in a linear temporal logic formula. We then specify a reactive, high-level task that involves stacking blocks in two different configurations, depending on the value of a user-defined variable switch. These liveness goals are shown on the right. The robot reacts to changes in the value of the variable switch and to non-determinism in its environment, such as when the block falls. Some user-defined specifications may be unrealizable, such as if we add the constraint that the green block, block 3, never be in location B, as shown on the left. In this case, we leverage the counter strategy to find a new skill for the robot that makes the specification realizable. In this case, a skill moving the block from C to F is found to repair the specification. With this new skill, the specification is now realizable, and the robot can find a strategy to once again react to changes in the value of the variable switch and to non-determinism in its environment.